Alright, so this is something I've talked about in other videos that I've had. I've had a lot of people asking me in recent videos on why am I not talking about the other isotopes? Why am I only talking about tritium? And people have been saying that Japan's only talking about tritium. They're not analyzing for other isotopes when there's other isotopes present. I think that this is mostly a communication issue, both on my part as well as on the Japanese government's part. Okay, so let's go ahead and start from square one here. We all deserve transparency when it comes to what's being released into the oceans. The oceans affect all of us. So the IAEA created this report, which is the first interlaboratory comparison on the determination of radionuclides in the Advanced Liquid Processing System treated water. This 72-page report goes into how they took the samples, how they did the sampling analysis, and what were the results. There were many participants and countries involved in this report. First, you had the IAEA, which has 3 different laboratories in Monaco and 2 in Austria. And then you have 4 more countries here involved, including Switzerland, France, United States, and Korea. A lot of people have been asking me, why has China not been involved? And honestly, I don't know that answer. Maybe in the future, that's something that they could do for transparency. So as the title of this report indicates, this is the first of several reports. In this one, they sampled just one tank group, and it's that first tank group that they were going to be drawing water from and releasing from the plant. So these tanks were all circulated together to create a homogeneous mix so that they could get a good sample result out of this. And these samples were taken under the observation of the IAEA, and immediately after they are taken, they put a tamper-proof tape over it and then shipped it to all of those facilities that I talked about. Now this might sound excessive, but this sort of independent testing and analysis and transparency is extremely important in these sort of situations. So here are the results that everybody's looking for in this report, and a lot of people have been asking about carbon-14, your iodine-129, cesium. They are all in this report here, and go ahead and pause to read. So why is it that me, as well as the Japanese government and other communicators, only talking about tritium and not all these other isotopes that are being analyzed for? Well, you can see that right here. Tritium is significantly higher than any other isotope that's reported here. In fact, carbon-14 is the one that's the next highest, and it's 10,000 times lower than tritium. And remember, these samples were taken directly from the tanks in Fukushima pre-dilution. The reason why they're having dilution is you can see right here, the tritium is over 150,000 becquerels per liter. And that is higher than what you can see in this chart here, which is the regulatory limits. And the regulatory limit for tritium is 60,000 becquerels per liter. So in order to get it down to the promised 1,500 becquerels per liter, they diluted it, and that made it to where it was significantly lower than the regulatory limit. So another reason why we're not talking about those other isotopes much, even though we probably should be, is this chart here as well. You can see that the carbon-14, which remember that was the highest one, is still about 100 times lower than the regulatory limit. And post-dilution, it's going to be 10,000 times lower than the regulatory limit. It's good to remember that regulatory limits, specifically these ones, are all significantly lower than what would be expected to cause any harm to people or the environment. I think this is another good lesson that I've talked about before. Just because you see something that's detected, like you saw in that previous table, does not mean that it's going to cause harm. So I took the liberty of taking all of this data from that table and plugging it into my own Excel sheets to determine what would be the dose of radiation that you would receive if you were to consume this water as your only water source for an entire year. And of course you wouldn't want to, because it's diluted with seawater. And I was able to determine that if you were to do that, it would be like eating 10 bananas per year, or consuming about 3.5 Brazil nuts over that entire year. The radiation that you would receive from those 10 bananas going through your body, or from the radium in the Brazil nut. So like I said in the beginning, transparency is super important here. So it's up to people like me who are science communicators and risk communicators to take that information that is out there, that's put out there, and explain it to the mass public.